At Novell, we understand that data centers with mixed IT environments are the reality for most organizations, and we know that data centers are evolving. IT's challenge is figuring out how to create an agile IT infrastructure, addressing power and space constraints, and delivering the performance, security, and availability the organization expects, all while trying to save as much money as possible. That's why realizing the benefits of a modern service-driven data center calls for a three-pronged approach: build, manage, and measure. With this approach, you can create a data center environment that adjusts and reacts to your changing business needs on demand, delivers the business services that your end users need, guarantees performance, and maximizes your IT infrastructure assets. Our job is to help you get there. Organizations are continually building, managing, and measuring their service-driven data centers to ensure they're meeting SLAs in the most efficient and effective manner. In this presentation, we're going to talk about one aspect of this continuous cycle: management. We'll talk about how workload management solves key data center challenges, a pragmatic approach to maximizing server consolidation investments, and how consolidated disaster recovery has transformed the business continuity market. The PlateSpin workload management solution from Novell addresses three key challenge areas in the data center. First, cost management, through our ongoing server consolidation and data center relocation capabilities. Second, performance management, through our virtual machine management and hardware migration capabilities. And third, risk management, through our disaster recovery and availability capabilities. Specifically, we'll talk about server consolidation and disaster recovery. There are many factors to consider when looking at business continuity solutions. Virtualization continues to be a primary IT technology. Server consolidation is an essential IT initiative. Companies are not realizing the full cost and performance benefits of virtualization due to poor consolidation ratios. And data centers are a mix of different platforms and hypervisors that require ongoing optimization. Server consolidation and virtual capacity management maximize your IT investments while delivering ongoing performance and optimization. One-time migrations and small-scale consolidation projects are easily handled by free migration tools and other basic physical to virtual products. Sophisticated management tools are typically not needed for these one-off projects. Enterprise-wide server consolidation initiatives, such as those being implemented in large and very large enterprises, require upfront planning and are part of a larger IT strategy to reduce costs and maximize server performance. Virtual capacity management is a post-consolidation ongoing IT initiative that companies are now embarking on. This solution focuses on profiling your virtual environment on a regular basis to right-size virtual machine allocation in an effort to reclaim unused server resources for new virtual machines. With current server consolidation ratios averaging between 3:1 and 5:1, enterprises are not capitalizing on powerful server resources that are capable of easily running up to 15 virtual machines with little risk and no additional technology. PlateSpin workload management is the only solution that can deliver cost, performance, and risk benefits when dealing with large-scale business-critical enterprise consolidation initiatives across multiple data center locations. Our virtual capacity management solution addresses these three challenge areas on an ongoing basis, maximizing your consolidation investments. One-time physical to virtual and small-scale consolidation projects deliver on cost but fail to address the risks associated with migrations and future performance challenges due to poor resource allocation and consolidation ratios. Our solutions are designed for large and very large enterprises that need to consolidate hundreds of servers. We can migrate even your most business-critical servers without taking them offline, moving them across multiple data centers located anywhere in the world. And our unique testing capabilities allow for risk-free workload migrations, providing you with the peace of mind in knowing your workloads will run in their new virtual environment. Let's take a quick look at our approach. The planning phase has three key parts: server inventory, utilization collection, and consolidation planning. PlateSpin Recon helps you discover and identify all the servers in your data center. Let's take a quick look at how PlateSpin Recon works.
Successful data center initiatives require considerable upfront planning and analysis to ensure a maximum return on investment. PlateSpin Recon is a sophisticated workload profiling, analysis, and planning solution that provides new levels of intelligence, visual analysis, and forecasting for optimizing the data center. PlateSpin Recon collects inventory and workload utilization statistics for a clear and concise picture of the application services running in the data center and how their resources are being used. With broad multi-platform support, PlateSpin Recon takes the guesswork out of server consolidation, disaster recovery, capacity planning, and green data center initiatives. Once Recon is set up, the next step is to inventory the workloads to be analyzed. For users looking to do capacity planning and what-if analysis for their virtual environment, physical hosts can be inventoried using the hostname, a CSV file, Windows domain, IP range, subnet, or using SNMP against the router. For organizations who've already adopted virtualization, users can inventory VMware's Virtual Center to get the list of ESX servers and virtual machines associated with an instance of Virtual Center. Here are the workloads that have been inventoried for this environment. Let's take a look at the properties for this server. The data that is collected as part of the inventory process is related to the platform this workload is running on, the operating system, processors, disk drives, network adapters, and even the applications that are installed. All of this data has been collected remotely and does not require agents to be deployed. The other type of data collected by Recon are the ongoing performance metrics. We'll just set this to view a longer time interval. Performance metrics include CPU, memory, disk, and network utilization values. These metrics are collected remotely every 5 minutes by default. This chart view shows the values of the metrics across time. For a more holistic, higher-level view, the user would now look at the reports included in Recon. It is here that the user can analyze the utilization trends of the environment, look for consolidation candidates for the next phase of their server consolidation project, etc. For a quick overall view of the inventory of the environment, look at the inventory report. This report gives a view of the hosts within the environment and the details of the operating system they're running. Here we get the same data, only this time represented in a graph. Now, for organizations looking to do capacity planning and what-if analysis for their server consolidation projects, the next step will be to go to the consolidation planning module. It is here where a user would specify the candidate workloads to be included in the plan, which virtualization platform would be used, the type of hardware that virtualization platform would run on, and how busy to allow that would-be virtual host to get before deciding there is no more for any new virtual machines. Here is a sample consolidation project. You'll see that it contains both scale-out and scale-up scenarios. For the scale-out scenario onto some smaller servers, it would require 5 virtual hosts to fit the potential virtual machines. For the scale-up scenario onto some larger servers, it would require only 3 virtual hosts. For a particular would-be virtual host, in this case running VMware ESX, here is a listing of a potential breakdown of virtual machines. If we click on this host and look at the chart, we can get an idea of what the 24-hour profile would look like on this server and how each would-be virtual machine would contribute to the utilization of this server. Here we have how this virtual host would look like from a CPU usage perspective throughout the day. Now memory. This can be done to see what is the bottleneck. Is it CPU, memory, disk I/O, or network I/O? Why am I not getting a better consolidation ratio on this virtual host? This has been a more ad hoc type analysis. There are also canned reports, as each scenario includes a summary report which can help build the business case for this scenario. It will answer questions like, how will this change the footprint within my data center? How much less rack space could I be using? How much less energy could I be using, etc. Once a scenario has been picked to be implemented, the user can point to a PlateSpin Migrate server and then point the would-be ESX servers to real ESX servers. This will then create jobs that can be modified and scheduled to be run. At this point, the next step would be to use PlateSpin Migrate to implement and execute the plan. What you've just seen is how PlateSpin Recon provides capacity planning as well as post-virtualization analysis to maximize the success of your virtualization initiative.
Now let's take a look at the three parts of the migration phase: migrating the workload, testing the workload, and making the new workload live. PlateSpin Migrate allows you to move your server workload without having to take it offline. This is an important feature when migrating business-critical workloads that you can't afford to take down. The testing process ensures the new workload will run as predicted in the new environment. Once testing is complete and you're ready to go live with your new virtual workload, PlateSpin Migrate lets you sync any changes that have occurred to the workload to ensure it's up to date. Let's take a look at how PlateSpin Migrate works.
PlateSpin Migrate is a workload migration solution that allows you to move server workloads over the network between physical servers, virtual hosts, and image archives. Migrate decouples the underlying server hardware and transfers workloads to and from any physical or virtual host. PlateSpin Migrate provides organizations with a mature, proven solution for testing, migrating, and rebalancing workloads across infrastructure boundaries from desktop to servers. Once Migrate is installed, the first thing you see is the server's view. The console consists of two split panes and lists of discovered sources and targets. Before you can begin, you have to discover a source and a target. These can be either a physical or a virtual machine. The back-end architecture consists of a Microsoft SQL Express database. WMI is used to communicate with Windows servers, and SSH is used to communicate with Linux and ESX servers. To discover a server, a hostname or IP address is required. Once the source and target have been discovered, you can select any of the following functions: copy workload, move, capture image, deploy image, and so on. Now I'll walk you through the process of a physical to virtual server move. We'll just click Move Workload here, and the wizard pops up. This wizard will guide you through the process of migrating or converting a physical server to a virtual machine. For this demo, I'll take the physical server NYSQL 2005 and walk you through the P2V process. We'll pick this ESX server over here as the target. Once we've picked the source and the target, we just click Start Wizard. As part of the P2V process, we can make changes to the workload. But before we can even begin, we need to have the right credentials. So for Windows servers, we need a minimum equivalent of a local or domain admin account. For Linux and ESX server, we need a root or sudo account. Now let's look at transfer methods. Take control is a cold migration process. This involves shutting down the source machine in order to migrate the workload. This is usually used for Linux and legacy Windows NT servers. In some cases, this process can also be used to migrate Windows 2000 and 2003 servers. The live migrations process is supported for Windows 2000 server and above. The process copies data from the source to the target without production interruption to the source machine. The live migration process consists of three different options. The first option is your typical file transfer. The file option is typically used for low transactional servers like web server and file servers. This option is not recommended for database servers or highly transactional servers. The block-based transfer option can be used for database servers and highly transactional servers. Migrate captures and stores the block layout of the drives and then streams the data block by block across the LAN or WAN without having to stop any services. The blocks are then reassembled. The data blocks and the blank blocks are then transferred and rebuilt to match the same disk geometry. The snapshot option utilizes VSS technology that is only available in Windows 2003. This is a file-based transfer option. The difference is, we can take advantage of Volume Shadow Copy service. This service allows Migrate to copy SQL database and Exchange databases without having to stop services. The hostname option is used mainly on the provisioning side for the purpose of cloning a server. You can change the name of the server, join a domain, and generate a new SID if necessary. Networking allows you to keep the existing network configurations such as the IP address, DNS, and WIN settings. Virtual machine configuration allows you to pre-configure the virtual machine name and CPU and memory settings for the target virtual machine. In volumes, you can select which drives will be part of the move. You can also increase and decrease the drive sizes before migrating the data. On this page, you can choose to stop, start, or disable Windows services. When migrating from a physical server to a virtual server, some hardware manufacturers' services that depend on specific hardware may cause the server to blue screen, so here you have the option to disable them. Now let's look at the advanced options. The advanced options allow for a more granular job configuration. The schedule option allows you to prepare migrations in advance, so migrations do not have to be run immediately. I can set up a job and then have it run at a later time. During the migration, you can receive an email with an up-to-date progress report on the migration job. When notification is turned on, the process will also alert you when a failure occurs and on completion. At this point, you have built a P2V job using PlateSpin Migrate. The only thing left to do is click Start and run the job. That concludes this brief introduction demo. You now have an idea of how PlateSpin Migrate can reduce the risks associated with workload relocation projects like server consolidation and data center relocation.
A recent study found that 76% of enterprises have declared a disaster or experienced a major business disruption. A similar study found that 87% of enterprises have indicated that improving disaster recovery capabilities was a critical IT initiative. Let's look at the two main solutions, high availability and disaster recovery, to see how they compare. High availability, primarily for application protection, leverages clustering technology and remote hot sites to ensure real-time recovery and availability. Disaster recovery, primarily for data protection, uses tape and imaging solutions to store data off-site in the event of downtime. High availability provides exceptional performance with near-zero recovery time objectives and recovery point objectives, two very important metrics when gauging the effectiveness of a high availability solution. The problem is that high availability also comes at a high price. Disaster recovery delivers poor performance with extremely poor recovery time objective and recovery point objective metrics, taking in some cases up to a week to recover and rebuild lost data. Considering the three main challenge areas data centers face today, cost, performance, and risk, high availability easily addresses performance and risk, but falls short on cost, forcing organizations to invest up to 80% of their business continuity budget. Disaster recovery is a price leader, but because it falls short in performance and risk, is not a practical way to do business today. PlateSpin Consolidated Disaster Recovery bridges the gap between expensive high availability and inadequate disaster recovery solutions, offering organizations a new way to cost-effectively protect servers in the event of downtime. If you look at how your typical disaster recovery budget is broken down, 80% is spent on protecting Tier 1 servers. These are your mission-critical servers vital to running your business. They also make up a small portion of your data center. The question is, how do you protect the balance of your servers with only 20% of your budget? Tier 2 servers are deemed business critical. That means you can afford to have these servers offline, but only for very short periods of time. Again, this group of servers requires more costly recovery solutions as extended downtime is not an option. Tier 3 and 4 servers are traditionally underinsured. These are important but not critical to the business and can typically be down for days before they're restored. Again, not a viable or practical solution. Growing business demands and advancements in technology have driven recovery time objectives, the measure of downtime, and recovery point objectives, the measure of data loss, to now be measured in hours instead of days. According to a recent survey, 46% of companies expect to recover mission-critical applications in 10 hours or less, and 28% of companies expect to recover business-critical applications in 10 hours or less. When it comes to limiting data loss, 65% of companies expect to limit data loss for mission-critical applications to 10 hours or less, and 51% of companies expect to limit data loss for business-critical applications to 10 hours or less. How long a server can be down is determined by your service level agreements. So, depending on your uptime requirements, there is a viable recovery and availability solution to meet your needs. PlateSpin Disaster Recovery and Availability provides exceptional performance, delivering uptime between 97% and 99.99% uptime a year. This translates to server downtime between 1 hour and 11 days in a single year. Server clustering offers the best protection, but does so at a high price. PlateSpin Consolidated Disaster Recovery Solutions not only meet all recovery metrics, but do so in a cost-effective way. For a similar cost, image capturing is not a viable solution, nor is manual tape rebuilding. PlateSpin Solutions leverage virtualization technology to create a consolidated recovery environment. They solve disaster recovery at a workload level, including the data, the application, and the OS. They replicate whole server workloads into a warm, standby, consolidated virtual environment. They give you the ability to run failed workloads directly off of the secondary system in the event of downtime. And they rebuild and recover servers to new or existing hardware in hours. Let's take a look at a protection scenario with PlateSpin Forge. Each PlateSpin Forge appliance lets you discover and protect up to 25 physical or virtual workloads. You can create customized protection plans that can capture and replicate changes on an hourly, weekly, or monthly basis, depending on factors like workload criticality and data change frequency. And while users continue to access the production workloads, your team can test the virtual machine copies in the Forge environment. When they're done, Forge can sync back up to replicate only the changes that happened during testing. You don't need to perform another full replication. And Forge keeps on replicating changes to the workloads based on the frequency you set up. Now let's take a look at a recovery scenario with PlateSpin Forge. When a production server goes down, the PlateSpin Forge web-based dashboard will alert you that a workload has failed. You can also receive notifications to your BlackBerry, enabling you to quickly recover by running the failed workload directly from the PlateSpin appliance. Then, you can easily restore the failed workload to the same or new hardware. Let's take a quick look at how PlateSpin Forge works.
With the PlateSpin Forge product design, our focus was to create an intuitive user experience. Let's go ahead and load up the Forge console. As you can see, the UI itself is a web-based thin client. All the user-initiated actions in Forge are as simple as navigating a website. Everything from configuration to testing to failovers are simply a matter of a few clicks. Once the Forge unit is configured and up and running, the first screen you'll see is this main dashboard. As you can see, the dashboard is divided into a few information panes. On the left-hand side, we have a graphical representation of the status of the protected workloads, along with some graphics showing the license and the disk usage. On the right-hand side is where Forge will track all past, present, and upcoming events. The first thing that users will probably want to do is add a workload to be protected. Doing this is very simple and intuitive. We just click on Add Workload here. Add Workload has taken us to a simple web form, where the user must now provide the hostname or IP address of the workload to be added and appropriate admin-level credentials. If Forge is able to communicate to a server through hostname or IP, Forge should be able to protect it. Again, very simple. Once the workloads have been added, they will appear in the Workloads tab. This tab really is the control center of Forge. As you can see in this tab, Forge gives a full inventory of all the servers being protected and any servers that have been discovered. If I check ny file serve, you'll see that Forge will intelligently highlight all the actions I have available for this specific server. This server has been discovered but has not yet been configured for protection. So let's go ahead and click on Configure Protection. Again, configuring a protection job is as simple as filling out a web form. The first group of settings are the protection tier settings. This is where a user can configure the intervals at which Forge will both monitor and replicate the servers being protected. This can be done with either default or user-defined templates, or simply custom configured for each protection job. The next group of settings are the replication settings. This is where a user can define the replication method, file level, VSS or block level, as well as the specific volumes the user wants Forge to protect. One interesting feature of Forge is that users have the option to leverage Forge for whole workload protection, but can also choose to use Forge in conjunction with other protection products to create a best-of-breed solution. The next group of settings are the failover settings. The two main attributes users will need to configure here are the resources that the recovery VMs will use at failover time, as well as the network configuration that these VMs will have to take on, so that users will be able to access them. Finally, the last group of settings is for test recovery. Forge has a very quick and easy testing capability, whereby Forge will create snapshots of the recovery VMs and boot them to a safe network environment for users to test as often as they choose. This is where users will define that test network configuration. Once all your servers are configured again, we can return to the Workloads tab. As you can see, in my demo environment I do have a server that has gone into failure. If I go ahead and click on this server, you can see that again, Forge will intelligently highlight all the actions I have available. In the case of this failed server, the two important ones are failover and prepare for failover. In the case of a failure detection, if a user were to click on failover, Forge would simply go ahead and boot the recovery VM in place and recover the appropriate network settings so that users would have access to its applications. Prepare for failover is a staged version of this two-step process, allowing users a greater level of control of the failover process for any potential troubleshooting that could be done before a failover is initialized. Finally, as you can see, if I check this LA file server that is running normally, you can see that a new action becomes available, which is test failover. Again, with Forge we've taken what previously was a very painful process, DR testing, and we've simplified down to the click of a button. Finally, let's take a look at some of the reporting capability of Forge. With Forge, users also have access to some pre-built DR-specific reporting. Let's look at a simple report called Current Protection Status. As you can see, this report gives users a great one-page view to all of the current performance of their Forge protection contracts and lists the RPO, RTO and TTO performance logged. From a performance standpoint, you can see in this report that with Forge, users are able to be up and running again in as little as 15 minutes.
In addition to the products you've just heard about, Novell and our partners offer a comprehensive set of consulting, training, and support services to help you get the most from your IT investment. So make sure to leverage our extended services team to reap all the benefits of your service-driven data center, faster and smarter. And also check out our website for many case studies of companies using PlateSpin to manage a service-driven data center. I hope you found this presentation helpful and informative. To find out more information about PlateSpin workload management solutions, fill out the form and a Novell representative will be happy to answer all your questions. Thank you.